Welcome. In this little tutorial, I'm going to show you how to build a language in MPS. We'll build a little state machine language with events, variables, states, transitions, and guard conditions by reusing an existing expression language. We'll also build a second language that tests the original state machine language, and we can even run this to execute the tests. Finally, we conclude by illustrating how to build tabular notations and diagrams as part of the overall state machine story.
All right, so let's build the test language. And of course, in good language design fashion, we're going to make this a separate language, right? So I'm going to call it state machine.test. Test. Hello. All right, and yes, I'm adding it to Git. So now the main element, of course, is the test case, and I'm making it a root so I can add it at top level. And I don't know, I can give it a name, but I don't really need one, right? But it doesn't really matter. So let's go here and say, okay, it's a test case wrapped in a horizontal collection with a name, and then use the proven ugly curly brace notation because we're not yet optimizing for notation yet. And I guess the test will have contents as well, so we'll use the same pattern, test case content, right? And we know that our test case has contents, test case content 1. By the way, I'm not 100% sure if this interface is called iTestCaseContent in the next commit that I'll build on. So next video it might be called iTestContent, but I assume you'll be able to deal with this. All right, so iTestCaseContent, and of course I'm putting a horizontal list here, indentation, and then the contents. I probably forgot to make this a list. You can see that because it doesn't propose the cell for the empty list, so I'm going to change this to 0 to n. And now if I make the contents, I get the list notation here. And I'm making it the vertical layout as usual, and an empty editable cell, otherwise it does these strange ugly double greater and smaller symbols. So I think we can make this language. And now we can hopefully, come on, go to our example model here. And remember, I made the test case a instance can be root, so I should be able to create one here. Of course I cannot. Why? Because this model here, the program I'm writing, does not yet include as languages the test language, right? So I'm going to include the state machine.test language here, and only then I can use the test case. That's how it should be, right? Because you only want to be able to see those language constructs of the languages you actually make available in the particular model you're writing. That's the whole point of language modularity. So, example traffic light test case. Now, of course, I want to specify which state machine I'm testing, right? So I want to refer to that thing. Okay, let's go back to the test case and add a reference machine. And now I want to reference the state machine. But of course I cannot, because this language at this point is still completely independent. So I'm adding a dependency to the language, to the state machine language. And if I do that, I can now see here, after it has refreshified, I can here now see the state machine. Exactly 1. And in the editor, I'll probably do it like, 4, and then of the selected state machine, the name, the usual reference syntax. And now I can select the state machine. Of course, this is already a go-to definition referencey kind of thing because all references are this way in MPS. So now what do we want to be able to put into the test case? Well, there's basically two things, as you saw in the initial introduction. You can either trigger an event into the state machine, or you check that it's in a particular state. So we have the assert, which is an I test case, whatever it's called, test case content, right? I'm sure it has the alias assert for assert state. And I have the trigger, which is also one of these test case contents. It's the keyword trigger. And so now the assert, of course, refers to the to one of the states, because I'm kind of checking if it is in a particular state. So I want to be able to mention the state I'm checking for. So that would be state. And I can see that concept again because it's from that other language. And now the editor is just an assert horizontal collection, and of the state the name. And same for the trigger. It triggers an event. So I see event from the other language, exactly one. And so the editor is again trigger horizontal collection events name. Now this should not be any surprise. There's nothing new compared to what we've done so far. There is one more thing, which is we only want to see those states and events in the machine for which we're testing, not those from the whole universe. So we need to implement scopes for the trigger, for the event reference in the trigger, constraint for the event. How would that work? Well, I mean, basically from wherever we are, from the context node, we're going up until we find our test case, right? We're somewhere under a test case here because the trigger can only be used inside a test case. So we're going up there. The context node might already be that test case, right? It depends exactly where in the tree where we are, how many levels down, and this plus here means that when we try to walk up the tree until we find the test case and the node on which we call the .ancestor is already the thing we're looking for, then it's returned as successful. In other words, plus includes the node on which we call it in the search for the thing we're looking for. So anyway, we know we have a test case. We can then wander over to our machine and ask it for the contents of concept event, right? That's what we're looking for. And then, as usual, we want to put this into a list scope from the JetBrains MPS scope language. Yes, please. List scope dot for named elements. I'm kind of cutting that thing here, right? And the exact same thing happens for the assert, right? Except that it's not an event, it's the state, and we're looking for the contents of concept state. Compile. Now we should be able to go here and assert that we're initially in the red state. I don't actually know. Yes, red is initial, right? So we're initially in the red state. Then we are triggering that pedestrian button and asserting we're in the green state. Okay? Because when we are in red and we receive the button, we go to green. So that's our testing language. You can do fancy things. For example, you can say, like, there's a checking rule here, TC. You can say if test case contents is not empty and test case contents first, if this is an instance of a assert, then that's good. Else, and you can say error, you should start by asserting the initial state first, right? You should always start any test by looking if the state machine starts with the correct thing. And now we can go one step further. If we know that this thing, right? We know that this thing is now an assert, right? We know that's an assert because that's what we checked here. So we can do an assert here. And the colon is the downcast operator for nodes. So this basically grabs the first of the contents and makes it an assert. And then we can basically say if the, let's call this, make it a good variable, s, okay, assert, assert, can't use the keyword in Java, s would have been better. Anyway, if assert.state is not the test case's machine's initial state, so we grab all the states, well, I guess we should be less ugly and create a behavior method. We've done that already in the last iteration, but the commit that I restored didn't have that. So node state initial state. So this is this dot contents of concept state. Find first where it initial, right? And now we can basically say here the machine dot initial state, right? If the thing we're asserting is not the initial state, then we can directly say the initial assert must assert the initial state, which is, right? And then we can do something like this dot name, okay? And we do that on the assert. So now if we do this, oh, there was an error. I forgot. So the compile error was that when we could try to compile the test language, it couldn't find the behavior. That's because we have added the behavior here, but then not compiled the state machine language. So let's do that. Alrighty, so now still doesn't work. Why? Now this is some live debugging test case. So the contents is not empty, and the first, yeah. So no, the first is an assert. If that's, yeah, want to get this one right. Actually, let's make this on the output the error on the contents first. Makes more sense. So now, right, you should start by asserting the initial state first. Okay, let's put an assert here. Now we get an error that says the initial state must assert the initial state, which is red, right? So I'm pointing this out because this is basically a little bit of static analysis. It's a very simple form of program analysis. You can do, of course, much more. We'll later see type systems. You can do data flow checks, all kinds of fancy things. This is a very simple one that gives you some guidance that you should start with an assertion over the initial state, and it even checks which state is that initial state. All right, so that's it for this one. In the next story here, we're going to build a generator.